Now let's see if we can use what we know so far to answer some questions about some linear functions without actually having to graph them all. So for example, the first question is, which function's graph is the steepest? We can see that function 1, 2, 3, and 4 are given in different forms, not necessarily all graphs, but it doesn't mean that we have to graph them all before we can answer this question, because we already discussed that a steeper slope would give, a slope that is farther away from 0, that's going to give us a steeper function, or a slope with a bigger absolute value, that's going to give us a steeper linear, steeper line, right? So all we have to do then is just to compare all the slopes after we find them, and then we can answer that question, okay? So let's look at the slopes of these lines, okay? So the first one, the slope is the same as the rate of change. So x is changing by 3 and y is changing by negative 18. So the slope of the first one is negative 18 over 3, which is negative 6. The slope of the second function, okay, so we have a point here that is 0, 5. The other point here is 1, 0. So the slope is the change in y, 5 minus 0, over the change in x, 0 minus 1. And that is going to give us 5 over negative 1, which is negative 5. And the slope of the third one, well, it just tells you is 2. Slope of the fourth function, mx plus b, m is the slope, so that's the number multiplying the x, so slope is 4. Okay, so if we compare negative 6, negative 5, 2, and 4, which number is the further away from 0, or in other words, have the biggest absolute value? Well, if we ignore the signs, 6 is the biggest number. So therefore, function 1 has the steepest graph. Okay, so we want to make a note here. I want to say that if we're looking at the steepness, we just look at the number, okay, not the sign, because the sign has nothing to do with the steepness. It just tells us the direction of the line. Okay, so the second question, which function has a graph with the y-intercept closest to 0? Okay, again, we don't have to graph it. We just need to compare the y-intercepts. So the first y-intercept is when x equals 0. So when x equals 0, that's negative 36. That's going to be our y-intercept. Now be very careful here, because we might look at this first pair and we go, oh, there's a 0 here. Okay, I guess negative 6 is a y-intercept. But that's not right, because when y equals 0, that tells us the x-intercept, not the y-intercept. That would have been the wrong point to look at. So we want to make sure that when we look at y-intercept, we're looking at when x equals 0. The second function, the y-intercept, is pretty straightforward. It's on the graph. It's where the line crosses the y-axis. So 5 is the y-intercept. Third function tells you it's 3. The fourth function, y-intercept, is the plus b part. So negative 1 is our y-intercept. Okay, so comparing all these numbers, which number is the closest to 0? Well, if you just draw them all on the number line, negative 1's here, 3, 5, and negative 6, 36, like way over here. So we can see that negative 1 clearly is the one that's closest to 0. Therefore, function 4 has a starting point, or a y-intercept, that's closest to 0. Okay, so the part C, which function has a graph with a slope greater than 0? Well, if we're looking at a slope that's greater than 0, we're looking at positive numbers for a slope. Okay, so it's not asking us for steepness, so we don't want to ignore the sign here. We do want to consider the sign as well. So we're just looking at a slope that's greater than 0, or the positive ones. So again, go back to the slope. We see that function 3 and 4, the slopes are 2 and 4. Those are the positive numbers. So we want to answer that, okay, then function 3 and 4, they are the ones with the slope greater than 0. So what this is useful is that if we want to see, say, okay, without graphing it, which function or which functions are uphill, you know, we can say, or increasing. Then we can say, oh, okay, we just want to find the positive slopes. Which ones? Oh, 3 and 4, because that's the slopes. So without even graphing, we can already predict that these two functions are going to be increasing or going uphill because they have positive slopes.